Welcome to today's lesson on identifying unknown ionic compounds. As we step into our lab, let's gear up with our lab coat, safety goggles, and gloves. While we're doing this, let's take a moment to recall what we've studied up to this point. We've spent much of this unit exploring chemical tests for ions, such as gas tests, flame tests, sodium hydroxide tests, and then ion tests. This part of a broader technique of chemical analysis, which is the area of chemistry concerned with identifying substances. This brings us to the exciting practical we're about to tackle. We have in front of us 3 mystery compounds. You will carry out a series of tests to identify these unknown ionic compounds. This experiment is a natural extension of our previous lessons, as it will allow you to apply your knowledge of ions and their behaviors to determine the composition of these mystery substances. Before we get started, let's take a moment to appreciate the significance behind the experiment. One of the most compelling reasons for mastering the identification of ionic compounds is its vast application in the real world. Industries such as pharmaceuticals, metallurgy, and environmental science rely heavily on understanding the composition of substances. For example, in the medical field, accurately identifying ionic compounds in drugs ensures their safety and efficacy. By learning these identification techniques, you'll be equipped with skills that are directly applicable to solving real-world problems and making impactful contributions to various fields. Secondly, conducting tests to identify unknown ionic compounds hones your analytical skills, an invaluable asset in both scientific and non-scientific careers. This practical experience demands critical thinking, keen observation, and methodical problem-solving. As you analyze the results, you'll learn to draw informed conclusions based on evidence, a process that mirrors scientific research and discovery. Such skills are crucial for success in the scientific community and beyond, emphasizing the importance of thoughtful analysis in tackling complex challenges. With this established, let's get into the practical. Let's begin by outlining basics. These ionic compounds contain a cation and an anion. To identify the cations, we can run a flame test or a hydroxide precipitate test. Identifying the anions is trickier. This could either be carbonate, sulfate, or halide ions, each of which has a different test. Accordingly, let's begin by doing a flame test to determine the cations. We will begin with mystery compound A. To conduct the flame test, we first dip a clean wire loop into a solid sample of the compound we are testing. Next, we put the loop into the edge of the blue flame from a Bunsen burner. Finally, we observe and record the flame color produced. Now repeat the flame test with compound B, which in this case turns the blue flame green. Finally, repeat with compound C, which has the same result. Ensure to carefully record these results as you conduct each experiment. Use your lab book to set up a table like this, with each compound listed and room for records of each test conducted. We can then fill the table in accordingly. We just conducted a flame test, which identifies the cations in a compound. In compound A, we saw a yellow flame, and in compound B and C, we saw green flames. Once these are recorded, we can check our observations against the flame test colors. With this, we can infer that compound A contains sodium ions, whilst compound B and C contain copper ions. It's worth noting that in an exam, you will not be provided with a table of chemical tests, so it is important to remember the observations for a flame test or any other chemical tests. Let's now determine the anions. We'll begin by testing for carbonate ions. Like last time, we will start with compound A. We add a few drops of dilute hydrochloric acid to a small sample of each of our compounds. Bubbles are produced if carbonate ions are present. Additionally, we can bubble the resultant gas through lime water. If it turns milky, this confirms the gas is carbon dioxide. When we do this for our compounds, we only see bubbling for compound A. In the case of compound B and C, there is no reaction. This indicates that there are no carbonate ions present and that we need to conduct further tests. Again, carefully record your observations in a table. For compound A, we observed that there was bubbling and that the solution turned milky when the gas was bubbled through. However, for compound B and C, there was no reaction. From this, we can infer that there are carbonate ions present in compound A, and as they turned lime water milky, they are carbon dioxide ions. This means that we've now identified mystery compound A's and ions and cations. When we balance the ions, it's clear that the salt is sodium carbonate. We still need to identify the anions for mystery compounds B and C. Accordingly, let's test whether sulfate ions are present in these compounds. Let's start with compound B. To do this, we take a small amount of the sample and add a few drops of dilute hydrochloric acid, then a few drops of barium chloride solution. A white precipitate forms if sulfate ions are present. For compound B, this white precipitate forms, indicating the presence of sulfate ions. However, when we test compound C, no white precipitate forms. This indicates that there are no sulfate ions present. Again, we must carefully record the results of the sulfate test in our table, indicating where changes were seen. Once we have done this, we can see that we have successfully identified the ions present in mystery compound B. When we balance these, it's clear that the salt is copper sulfate. We're not done yet though. We need to find the anion for C. Let's test whether it's a halide ion. You might recall that the test from earlier in this unit. First, we add a small sample to a test tube, then add a few drops of dilute nitric acid, then a few drops of silver nitrate solution. We then observe and record the color of any precipitate formed. If halide ions are present, the color will depend on which halide ion is in the solution. When we do this for compound C, we see a cream precipitate forms. Recall that this is characteristic of the bromide ions. Now we can finish our table of results. For compound C, we can see that copper ions and bromide ions are present, meaning that overall, this is copper bromide. And with that, we've found the identities of our mysterious compounds. A was sodium carbonate, B was copper sulfate, and C was copper bromide. In this experiment, it is important to have a good knowledge of the chemical behavior of ions. Without this, we wouldn't be able to make any inferences from our observations. In the same way as a mathematician needs to know the formula for the area of a circle, chemists need to know identifying reactions of ions. In today's lesson, we embarked on a fascinating journey to unveil the identities of unknown ionic compounds through a series of systematic tests. We conducted a flame test to observe distinctive color changes, revealing metal cations. Further, we tested for carbonate ions using hydrochloric acid and examined the presence of halide and sulfate ions through specific reagent reactions. Throughout this experiment, we honed our ability to interpret visual and precipitate-based clues to identify ionic compounds, enhancing our understanding of how ions interact with various reagents to produce observable results. This knowledge is essential for future practicals as it reinforces key analytical chemistry concepts and strengthens our laboratory skills. Remember to apply this systematic approach in your experiments and continue to engage with the wonders of chemistry safely and inquisitively. Watch the rest of the GCSE chemistry course at Sophos Education.